Today we're going to go over the review for our final exam on Earth history. So we're going to start off with some of the review questions. There are 20 of them. The first one, which of the following landforms occur at different locations on Earth? The landforms that occur all over the Earth's surface, some of the examples are mountains, valleys, canyons, plateaus, rivers, lakes, beaches, oceans, deserts like sand dunes. And there are other examples, things like deltas, river meanders, inland seas. Okay, just to name a few. Most of these landforms are shaped by slow, persistent processes that proceed over the course of millions of years. The next question, what are some of the ways that rocks get broken down? Now, with one or two of the classes, I forgot to put this question on there, so make sure if you were in some of the morning classes or earlier classes that you check to make sure you have this question. And the way that some of the rocks get broken down is through weathering into sediment by a number of processes, and specifically we're going to focus on physical and or chemical weathering. Sometimes they happen together. More often than not they do. Some of the examples of physical weathering would be frost wedging or roots splitting them apart. Some of the examples of chemical weathering would be acid rain or oxidation. The third question here, why do there appear to be strips on the walls of the Grand Canyon? And we have our answer. The different rock layers make up the walls, have different characteristics which make them look different. Sedimentary rocks always form flat and horizontal layers, so they appear in stripes because they are different rock layers deposited at different times and they have different characteristics. How are the rocks from the two Grand Canyon sites related to each other? And we're talking about the rock layers. Rock layers are huge and they extend over very, very large areas, much larger areas than just the Grand Canyon. They're going to extend over areas that might affect multiple states or multiple parts of a continent. So they are extremely massive. Things that form these rock layers would have happened to huge areas of the Earth's surface. So that's why they're going to extend over these large areas, and we're going to find those same rock layers at multiple parts on the Earth's surface. The next question here, which came first, sand or sandstone? And our answer to that is that sandstone would have come first and needed to be there to create the sandstone. Igneous rocks would be the first type of rocks on the surface of the Earth. They would have been broken down into sediment, and that sediment would have gotten deposited in something like a basin, would have gotten glued together, compacted, and then eventually it would have become a sedimentary rock. The next question, what happens to sediments that get deposited in basins? And we have our answer here, sediments in basins will get glued together and become sedimentary rocks over time. They're going to lithify or harden and glue together. Those sedimentary rocks will always form in flat horizontal layers. Question 7. What are some non-renewable resources and some renewable resources? We can see the answers here. Non-renewable resources, nuclear and fossil fuels. With the fossil fuels, things like coal, the anthracite that we went to see at McDade Park, oil, which would also include petroleum and gasoline for cars, and natural gas. And we talked about some of the different things with fracking as well in class as we try to extrude the natural gas from the Earth. Some of the renewable resources are solar energy from the sun, wind energy such as from turbines, water or hydroelectric energy, geothermal energy, heat from inside the Earth, biomass, things like wood or plant matter. Question 8, sticking with our topic of energy sources, what's the difference between renewable and non-renewable resources? Okay, with renewable resources, just like the word says, they're renewable, they're not going to run out, they can be reused, but they are not as efficient at producing energy so they are not as effective either. So it takes a little bit more. Also, they cost a little bit more because you need to have more of them to produce the same amount of energy. With the non-renewable energy source, eventually they are going to run out. There is a limit on how much there is in the Earth's surface or in the crust. However, they are more effective and efficient at producing energy, and in many cases they are cheaper way of producing energy. So that's why they are more useful today. Question 9. What do sedimentary rock layers reveal about ancient environments? We have here for the answer. They can tell you what happened to the surface of the Earth at different times in Earth's history. Also, the processes we observe today probably acted in the same way millions of years ago. This principle of uniformitarianism, things that happened millions of years ago, or processes like weathering and erosion, probably happened the same way millions of years ago as they do today, and as they will occur in the future. So we can draw conclusions based off of what we witness today on what happened years ago and what's going to continue to happen. That's why we look at our model of the Grand Canyon, something that happened 5 million years ago, and we can kind of draw conclusions on how the Grand Canyon actually formed. Question 10. Looking at a rock sequence, how can you tell the oldest rock layer? The older rock layers are always at the bottom, and the newer rock layers are at the top. This principle of superposition, if you will, is very, very simple. The rock layers always have to form in this way. Older rock layers are always going to be at the bottom, and the newer rock layers are always going to be at the top. And this mainly deals with sedimentary rocks. Question 11. How do fossils get into rocks? A fossil is any remains or trace that imprints themselves, a plant or animal, that's preserved in the Earth's crust during the ancient times. So anything that's going to leave a mark in a rock that we can look at millions of years later, or hundreds of thousands of years, whatever the case may be, but they're going to basically imprint themselves into that rock, or that object's going to get pressed into that rock. Question 12. How do we categorize extremely long periods of time? When we're talking about geological time and timelines, we're going to be talking about things like eons, which are the biggest, longest periods of time. Then eras, which is what we started with in class, and we talked about the 3 main eras, the Paleozoic, the Mesozoic, and the Cenozoic. And then the different periods, and the periods would be found within the different eras, and that's where we get into things like Jurassic, Triassic, Cretaceous, the different periods that would make up the Mesozoic era, for example. Question 13. How do igneous rocks form? Igneous rocks are going to form from heat inside the Earth, melting down the rocks into in the mantle or into magma. And the rocks are going to come up usually through volcanic activity back near the surface, and that magma and lava, when it gets to the surface, will cool and form igneous rocks. Sticking with the topic of igneous rocks, question 14. What affects the crystal formation in igneous rocks? This is a longer one. Molten rocks cool quickly at the surface of the Earth and can be identified by small mineral crystals. Molten rocks that cool more slowly inside the Earth are intrusive and have large mineral crystals. And again, if they cooled quickly at the surface of the Earth, they're considered extrusive and have small crystals. So we get back to that idea of intrusive and extrusive igneous rocks. Intrusive inside the Earth, extrusive on the Earth's exterior. Moving on to question 15. Why do earthquakes and volcanoes occur? Where do they occur? At the same places, and where do they occur? Earthquakes and volcanoes occur along plate boundaries. Plate movements result in plate boundary interactions that produce volcanoes and earthquakes, as well as continental drift. So the interactions and the movement of these tectonic plates are going to cause or lead to earthquakes and volcanoes on the surface of the Earth, and that's why we see them in similar areas. One of the main areas we focus on is what we call the Ring of Fire, which kind of goes around the Pacific Ocean. Sticking with that idea, what causes the plates or the tectonic plates to move? The tectonic plates float on top of the mantle, and the plates move due to the flow of convection currents in the mantle. That's an important one to understand why we have this jigsaw-style crust. It's made up of all kind of puzzle pieces, if you will, and they interact and move around. And the reason that they move around is due to convection currents or heat deep inside the Earth, and it causes them to move almost like a conveyor belt. Question 17. What are some ways that mountains form? Sticking with this idea of plate tectonics, the interactions between these tectonic plate boundaries deform the plates, producing different landforms. Mountains form as a result of these plate interactions. We talked about the car accident, or the way a hood of a car will crumple and kind of fold up, and that's where we get these mountains forming in many cases from these tectonic plates colliding with each other and starting to fold as they interact with each other. Fold mountains. Question 18. How do metamorphic rocks form? When tectonic plates interact, high heat and immense pressure can change rocks into new forms of rock, and that's metamorphic rocks. And a lot of times this happens with mountain building, and that's where we get our formation of metamorphic rocks in the rock cycle. Our next question has to deal with the rock cycle. What is the rock cycle? The rock cycle describes how each rock is constantly being recycled and how each rock type can be transformed into other rock types. So kind of the recycling of the rocks as they change from one form to another, and the different things that need to happen to them as they change forms. And our last question, how does the rock cycle show the change in form from one type to another? Now I have here used the diagram that we discussed in class. That diagram would be our rock cycle diagram, which I'm going to pull up right now. Oh well, I can't find it. But if you have any other questions, I gave out handouts on the rock cycle. You can use those or come get another one. And if you have any other questions, make sure to stop by in class and ask.